Hey there, hope you're having a wonderful day. In this video, we're going to be coding the game Pac-Man in Java. So what you see here is the final result of this tutorial. And currently we have game over, but if I press any key, it will restart the game. So let's press a key, and you can see Pac-Man is moving around, collecting the food pellets. And if Pac-Man hits a wall, it stops moving. And I can change directions, so I can move right, down, left, down, and if Pac-Man collides with the ghost, on the top left corner, you can see we lose 1 life. And again, I just collided with the ghost, and now I'm down to 1 life. And if I collide with the ghost one more time, we get game over. And of course, if I press any key again, it will restart the game, and I can continue playing the game. Okay? Alright, so before we start coding the game, I just want to quickly mention that on my YouTube channel, you'll find various tutorials. So currently I'm working on data structures and algorithms in Python and beginner C++. And I have many game tutorials. So I have tutorials for Python. So I have games such as Snake and Tic-Tac-Toe. And for Java, I have match cards with Pokemon cards, Space Invaders, Flappy Bird, Blackjack, Minesweeper, Snake, and so on. And for JavaScript, I have Doodle Jump, Breakout, Flappy Bird, Space Invaders, Wordle, 2048, Minesweeper, Candy Crush, and so on. So if you want to stay up to date on any new tutorials, make sure you subscribe to the channel. And again, you can find the list of tutorials on my channel as well as on kenyipcoding.com. Alright, so for this tutorial, I will be using Visual Studio Code. And if you want to learn how to set up Visual Studio Code with Java, I have a tutorial on that, and I'll link the video in the description below. Alright, let's begin. Press Ctrl-Shift-P at the same time. Look for Java, create Java project. No build tools. And I will create this project on my desktop. And for the project name, I will call it Pac-Man. Alright, I have my project folder, and within my Pac-Man folder, I have this source folder with app.java. And this is going to be our main file where we run our code. So I can just click on this run button, and you can see we get hello world. Alright, so the first thing I want you to do is go to the video description and click on the GitHub link. The GitHub link will contain the completed code for the Pac-Man game, as well as the images that we need for the game. So click on the GitHub link and download those files. And here you can see we have our images. We have the blue ghost, orange ghost, pink ghost, and red ghost. And we have these Pac-Man directions. I've also included the scared ghost and the cherry, but in this tutorial, we will not be implementing those features. Instead, I just want to focus on the ghost and the Pac-Man. But yeah, once you downloaded the files, just take the images and drag and drop them to your source folder. So you should see these images. Alright, so now they're all in my source folder. Alright, so after you've done that, let's start coding. Now the first thing we need is a window for our game. So I'm going to delete this line. And over here, I'm going to import javax.swing.jframe. And the jframe is going to be our window. So before we create our window, we need to determine how big we want the window to be. So we need to specify a width and a height. So here we have a tile map, which represents the map of our game. And we're going to divide the game window into tiles, or squares. In this case, we have 19 columns. So starting from 0 to 18, because index starts at 0, we have from 0 to 18, that is 19 columns. And for the rows, we have 0 to 20. So in total, we have 21 rows. And each one of these tiles is 32 pixels by 32 pixels. So this means that the width of our window, going from left to right, is 19 columns times 32 pixels. And likewise, the height is going to be 21 rows times 32 pixels. Okay, so that's how we're going to define the width and height of our game. And In a bit, I'll explain how this tile map works. So let's go ahead and define some variables. So we have an int row count, and I'm going to set this to 21. An int column count, this is going to be 19. And we need to define the tile size. So int tile size is equal to 32. So this means int board width is equal to column count times tile size. And int board height is equal to row count times tile size. Alright, so we have our width and height. Now let's create our window. So I'm going to create a jframe. And the frame is basically the window. So we'll call this frame is equal to new jframe. And here I can pass in a string that will be the title of our window. So I'm going to call this Pac-Man. And let's make the window visible. So frame.setVisible. And I'm going to set this to true. And I want the window to appear at the center of our screen. So frame.setLocation relative to. And I'm going to make this null. And let's make it so that the player cannot resize the window. So we don't want the user to use the mouse to expand the width and height of the window. So frame.setResizable. And I'm going to make this false. And finally, we want the game to terminate if the player clicks on the X button of the window. So I'm going to do frame.setDefault closing operation jframe.exit on close. Alright. Oh, and one more thing I almost forgot. Let's set the size. So frame.setSize, and I'm going to make it board width and board height. Alright, let's save and run the program. And you can see we have our game window. Alright, so we have our window. The next thing we need is a jpanel. And the jpanel is what we're going to be drawing on to show our game. Now, I could make a jpanel here, but instead what I'm going to do is I'm going to create another Java class file. So I'm going to go to source folder, right click, new Java file, and I'm going to select class. And here I'm going to call it Pacman. So the idea here is I'm going to have Pacman inherit jpanel. And for those of you who don't know what inheritance means, basically I'm going to have this Pacman class inherit the jpanel class so that this class is basically a version of jpanel, except I can add more properties for the game. So here I'm just going to import a few things. So import java.awt.asterisk, import java.awt.event.asterisk, import java.util.hashSet, and then import java.util.random, and import javax.swing.asterisk. Alright, so we're going to have Pacman inherit jpanel, so I'm going to have this Pacman class extends jpanel. And here I'm going to define a few properties. So I'm just going to copy and paste this and paste it over here. So our jpanel will have the same size as our window. So I'm just going to make these properties private. And now let's create a constructor. So Pacman. And I'm going to set preferred size. And for preferred size, I need to specify a dimension. So I'm going to create new dimension, board width, and board height. And for the game, I'm going to make the background color black. So set background color dot black. Alright, so we have our jpanel, and I'm going to go back to our app.java file. And I want to create an instance of this jpanel now. So Pacman game is equal to new Pacman. Alright, so we have the jpanel, and I need to add this panel onto our window. So frame.add Pacman game. And we want to make sure that we get the full size of the jpanel within our window. So I'm going to do frame.pack. And here I'm going to copy and paste this. So usually you don't want to set your window visible until you have all the components in the window. So I'll make the frame visible after I've added the Pac-Man game jpanel. Alright, now let's save and run the program. And you can see we have our Pac-Man game, and you can tell because the background color is black. Alright, so we have our window. Now we need to create the game. And the first thing I want to do is load the images for our game. And for the images, we're going to create member variables to store the images. And the first one is going to be the wall image. So private image wall image. Next, we need to load the images for the ghost. So I'm going to create member variables for the ghost images. So private image blue ghost image. And I'm just going to copy and paste this. And I'm going to change each one. So this one is going to be orange ghost. Then we have pink ghost. And then red ghost. Alright, so make sure the images are spelled correctly. And then finally, we have another 4 set of images. And this will be for the Pac-Man. So private image, Pac-Man up image. And I'm going to copy and paste this. And we're going to change this to up, down, left, and right. And in our constructor, I'm going to load the images. So let's load the wall image first. So wall image is equal to new image icon get class dot get resource. And here we need to specify the file path of where the image is. So get class refers to this Pac-Man class, and this file is located in our source folder. And our images are located in the same folder. So here I'm going to do string dot slash. So the dot slash means that we are going to look from the same folder as the starting point, and we just need to specify the image name. So the wall is going to be wall.png. And so this is going to create an image icon, but instead we want the image. So I'm going to do dot get image. All right, and I'm just going to repeat this for the ghosts and Pac-Man. And all of these images are PNG files, so they're not animated. So we're going to have static images. Unfortunately, I couldn't find the sprites for the game, so I had to create the pixel art myself. But yeah, so let's just continue loading the images. So I'm just going to copy and paste this. And here I'm going to change this to blue ghost image. And the file name is called blue ghost. So blue ghost. And I'm just going to copy and paste this. This is going to be orange ghost image. And we're going to change this to orange. And then this one is going to be pink ghost image. And we're going to change this to pink. And we have red ghost image. And we'll change this to red. And let's do the same for Pac-Man. So this will be Pac-Man up image. And this will be called Pac-Man up.png. And let's just copy and paste this. And this will be down, Pac-Man down, left, left, right, and right. And make sure the image names are all correct. So that's all you need to load the images. And these images will be stored in these variables. All right, the next thing we need to talk about is the tile map. So here we have a tile map, and this is basically how we're going to map out all the tiles in our game. So this is going to be represented as a 2D array, and I will be using characters. You could use numbers, but I will use characters because I think it's easier to write out. So I'm going to use an array of strings. An array of strings is basically an array of characters. So you can think of each row as a string within our array. Each tile is going to be represented by a character. And if the character is an X, this means we need to place a wall here. And we have empty tiles. So this is a white space. In this case, if we have a white space, I'm going to place a food here. Now in a lot of games, if it's actually empty, then we make it nothing, but I'm going to do the opposite. So this O here means that it is empty. So it's a lot easier for me to just place a few O's here instead of putting O's everywhere. Okay, so remember, basically, if it's a white space, we're going to place a food. And if it's an O, that means no food, it is empty. And then we have R, B, P, and O. These are all in lowercase. R stands for red, B stands for blue, P is pink, and O is orange. And the reason why I use lowercase is because Pac-Man also starts with P. So I'm going to represent Pac-Man with an uppercase P. And I'm going to iterate through our tile map and create objects. So how this works is I'll start at 0, 0. So 0, 0 is the top left corner of our screen. So if I want to say, what is this point here for this tile? We have 1, 2, 3, 4 for the x-axis. So 4 to the right. And we have 1, 2 down. So the xy coordinate for that tile is going to be 4, 2. But remember, this is 4 tiles to the right and 2 tiles down. So pixel-wise, we need to multiply each one by the tile size, 32. So this is going to be 4 times 32, which is 128 pixels to the right, and down will be 32 times 2, so 64 pixels down. Okay, and from here we need to specify the width and height. So the width is going to be the tile size, which is 32 pixels, and the height is going to be the tile size as well, so 32 pixels. So starting from here, we're just going to iterate through our tile map. So we start at 0, 0 at the 0th row, and I check, is there an X here? If so, we have a block. And then I jump to the next column, which is the next tile size over, and I see there's an X, so I create another block. And then I jump to the next one, and then the next one, and so on. And then after I clear this row, we have our second row, which is at index 1. So here we have an X, so that's a block. And then I jump to the next one. This is empty, so I put a food here. Jump to the next one. This is empty, so I put a food here. Jump to the next one. This is empty, and I put the food here, and so on. Basically, we iterate through the tile map, and if we get an X, we create a block. And if we get R, B, P, or O, we have a ghost. And if we have empty tile, that is the food. And the P is Pac-Man. So we have 3 things that we have multiple of, which is the wall block, the food, and the ghost. So I'm going to store all of these in 3 different hash sets so that we can iterate through them. The Pac-Man, since there's only one Pac-Man, we do not need to store a Pac-Man in a hash set. So I would just create a Pac-Man variable for Pac-Man. And the reason why I use a hash set instead of an array list is because if you know your data structures and algorithms, when I check for collision, it is easier to search in a hash set instead of an array list. So this is just for performance purposes. A hash set is very similar to an array list if you don't know. You can look it up later on. But it's pretty much similar to an array list, except the performance is better for looking up values. And in a hash set, all the values are unique, so you can't have duplicates. In this case, we're not going to have any duplicate objects. Alright, so in order to draw each image, I need to specify where it is, so the X and Y position, and the width and height. And I need to store all of this information for each wall, food, and ghost, and the Pac-Man. So the best way to store this information is just create a class to represent this object. So I'm going to create a class called block, and we have a few things. We have the X position, Y position, width, height, and image. And just for restarting the game, we want to save the original X and Y starting positions because as the game goes on, the Ghost and Pac-Man will be moving around, so the X and Y positions will be changing. So we need to save the starting X and Y positions. Alright, now let's create the constructor. And I'm going to take in an image, the X position, the Y position, the width, and the height. So this dot image is equal to image. This dot X is equal to X. This dot Y is equal to Y. Width, height, and we're going to set the start X equal to x as well, and start y equal to y. And down here, let's create some hash sets. So hash set of block, and I'm going to call this walls. We'll create another one. This will be foods. And then we have ghosts. And finally, we just have one block to represent Pac-Man. Alright, so now we have our representation of the objects in our game. The next thing we need is the tile map. In my case, the tile map is going to be an array of strings, which is an array of characters. Alright, so for the tile map, I'm just going to copy and paste it here. And I will leave this piece of code in the video description. You can also get this code in the completed code from the GitHub repository. So here we have an array of strings, and each string is a row within our game. So again, X is the wall, O is just skip, don't do anything. Uppercase P is for Pac-Man, and the white space is for the food. And of course we have the ghost, so B is blue, O is orange, P is pink, and R is red, which is over here. Alright, so we have our tile map, and now I want to go through the tile map and create the objects for the walls, foods, ghosts, and Pac-Man. So down here, I'm going to create another function, public void, and I will call this load map. So in the beginning, I need to initialize all the hash sets. So walls is equal to new hash set of block. Foods is equal to new hash set of block. We have ghosts, new hash set of block. Alright, so now we need to iterate through the map. So for int r, so r stands for row, equals 0, r less than row count, r++. For int c is equal to 0, so c is for column, c less than column count, c++. I'm going to get the current row, so string row is equal to tile map index of r, and we need to get the current character, so car tile map car is equal to row.car at c. Alright, so we have the character at this specific tile, but we need to figure out where this tile is. So remember, to draw, you need an x and y position, as well as a width and height. So the width and height are going to be tile size. So we just need the x and y position. So to get the x position, we need to see how many columns we are from the left. So this is c times tile size. So how many tiles from the left. And the y position is going to be how many rows from the top. So r times tile size. So just very quickly, if I want to know what is the x and y position of this tile, we need to know how many tiles from the left. So how many columns? 1, 2, 3, 4. So this is 4 columns, and we multiply this by tile size, which is 32 to get the actual pixel value. And for the y position, it is 1, 2, 3. So this is 3 tile size. So 3 down. So this will be 3 times the tile size. Okay, so we are calculating the x and y position every time as we iterate through this 2D array. Alright, so if tile map character is equal to x, this means we have a wall. So I'm just going to create a block wall, new block, and we need to pass in the image x, y, width, and height. So wall image, x, y, tile size, and tile size. And then we just need to add this block to the wall's hash set. So walls.add wall. Now if it's not an x, else if tile map car is equal to lowercase b, this is the blue ghost, so I'm going to create a block called ghost, new block, blue ghost image, x, y, tile size, tile size. And then we do ghost.add ghost. So let's copy and paste this for the other 3 ghosts. And this one is going to be the orange ghost. So orange ghost image. And then we have the pink ghost. So pink ghost image. And finally, we have the red ghost. All right. And then we have else if tilemap car is equal to uppercase P, that is Pac-Man. In this case, we will do Pac-Man is equal to new block. And by default, I'll just have Pac-Man face the right side. So Pac-Man right image, X, Y, tile size, tile size. Else if tilemap car is equal to a white space, and that is the food. So block food is equal to new block. In this case, we don't have an image. Instead, I would just programmatically draw a rectangle. So for image, I will set it to null. And this will be a little tricky, so we need to do some math here. The rectangle is going to be small, so it's not going to be 32 pixels by 32 pixels. So for the X and Y position, I will create an offset of 14. So X will be X plus 14 and Y will be Y plus 14. And the width is going to be 4 pixels and the height is going to be 4 pixels. And then I'll do foods.add food. So basically for the food, we have this tile and we want the tile to be in the middle like so. So we have 4 pixels by 4 pixels. We need to fill in the gap. So if the height and width are both 32 pixels, we do 32 minus 4, that's 28. And then we divide it by 2, which is 14. So 14, 14. So this means we need to take this tile, starting from the top left corner, move right by 14, and then move down by 14. And then from here, we can draw the food. All right, and that's it for our map codes. We do have one more, which is the big O, which is empty, skip. So there's no point in me adding that check because we're not going to do anything. So in our constructor, I'm just going to call it load map. And let's just add some print statements to see how many walls, foods, and ghosts we have. So system.out.println walls.size. And then let's do the same. Foods and ghosts. All right, now let's save and run our program. And we get 196 walls, 184 food pellets, and 4 ghosts. And of course, we have our game window. All right, so we know our load map is working. We have all the objects in our hash sets, so I'm just going to get rid of these print statements. All right, so now that we have our objects, let's draw all of them onto our game. So down here, I'm going to create a new function called paint component. And it's going to take in graphics G. And I'm going to do super.paint component. So basically, it's going to invoke the function of the same name from jpanel. So that's what super does. And then after that, we can just call a draw function and pass in G. So down here, I'm going to create a draw function that takes in graphics G. So as an example, I'm going to show you how to draw a rectangle. So if I want to draw Pac-Man right now, we have Pac-Man as a block object. And it has the information X, Y position, and the width and height. So I can do g.fillRect, pacman.x, pacman.y, pacman.width, and pacman.height. And now if I save and run the program, we get our Pac-Man over here, okay? So instead of a rectangle, I'm going to draw an image. So this will be g.drawImage. And the parameters are similar, except we need to place the image in the front. So pacman.image. And at the end, I'm just going to pass in null. So there are 6 parameters. And the last one we don't need. So I'm just going to pass in null. And let's save and run the program. And as you can see, we have Pac-Man over here. All right, now let's do the same for the rest of the objects in our hash sets. So for block ghost, we're going to do g.drawImage, ghost.image, ghost.x, ghost.y, ghost.width, ghost.height, and null. And if I save and run the program, you can see we have our 4 ghosts over here. And let's do the same for the walls and food. So for block wall, walls, g.drawImage, wall.image, wall.x, wall.y, wall.width, wall.height, and null. And let's do the same for the food. So block food, foods. And remember, we don't have images for the food. Instead, we're drawing rectangles. So I'm going to do g.fillRect, food.x, food.y, food.width, and food.height. And before I do this, I'm going to set the color to white. So g.setColor, color.white. All right, now let's save and run the program. And here you can see we have our map. And what's cool about this is, now that I have my code to load the map, I can just modify the tile map here. So let's say Pac-Man is over here. I can add an X here and an X here. And if I save and run the program, you can see I've just added a block to the left and right of Pac-Man. But I'm going to undo that. And basically, I want to encourage you to design your own tile map if you want. And you can create your own layout for the Pac-Man game after this tutorial. But yeah, let's continue on. So we have our tile map, and we have all the walls, foods, and ghosts, and we're drawing all the objects. Now the thing here is, when we run our code, this paint component only gets called once, and therefore we only draw one time. Now in a game, we are constantly moving all the characters, so the ghosts and Pac-Man move up, down, left, and right, and we need to constantly redraw on the jpanel to reflect those new positions. And to do that, we need a game loop. And here I'm going to implement action listener. And I'm going to hover over Pac-Man, and you can see we need to do a quick fix, because if we implement action listener, we need to implement a method. So if I scroll down, you can see we need this action performed method. So this is going to be used for our game loop. And what we need to do is repaint. So repaint is going to call paint component again. And in order for this code to execute, we need a game loop, which is a timer. So let's scroll up. Over here, I'm going to create a timer called game loop. And then within our constructor, I'm going to do game loop is equal to new timer 50 this. So we have 2 parameters, 50 and this. 50 is the delay, and this refers to this Pac-Man object. So when we use a timer, we need an action listener. So instead of creating a separate action listener object, I'm going to have Pac-Man take on the properties of action listener. And we just need to define the things we want to repeat in our action performed. So every 50 milliseconds, we are going to call action performed, which we'll call repaint. Okay, so basically every 50 milliseconds, we're going to repaint, and there are 1000 milliseconds in 1 second. So 1000 divided by 50 gives us 20. So this is 20 frames per second. And after we create our timer, we need to start it. So game loop.start. So now if I save and run the program, we have our game, and it's running in a loop. It's drawing over and over again, but we don't see the changes because Pac-Man and the ghosts are not moving. So let's add some key listeners so that when we press the arrow keys, Pac-Man will move up, down, left, or right. So up here, I'm going to implement key listener. And just like with action listener, we have some unimplemented methods. So if I hover over Pac-Man and click on quick fix, add unimplemented methods, you can see on the bottom, we have 3 methods: key typed, key pressed, and key released. So key typed is when you type on a key that has a corresponding character. So for instance, if I press A, we get the letter A, or if I press 0, we get the number 0. But if I press the arrow keys, nothing happens because the arrow keys don't give us characters when we're writing. So we're not going to use this. Next, we have key pressed. And key press is basically when you press on any key. So I can press on the arrow keys, I can press on any key with a letter. As long as I'm pressing the key, I would trigger this function. And actually, I can hold on to the key as well. Now, we don't want to hold on to the key, so I'm going to collapse that. The only thing we need is key released. So key released is similar to key press, except it only triggers this function if we press a key and we let go and we release the key. So if I press a key and I hold on to the key, nothing will happen unless I let go. So for now, we're just going to add a print statement. So system.out.println key event plus e.get keycode. Now we need to make our key presses work. So in our constructor, I'm going to add two things. One is add key listener, and I'm going to have it listen to this. So when Pacman implements key listener, it takes on the property of a key listener. So I don't need to create a separate key listener object. I can just reference Pacman. And so if I add key listeners, it's going to listen for key presses and use these three functions to process the key presses. Next, I want to make sure that the jpanel is the one listening for the key presses. Now, in a window, you can have multiple components and they can all be listening for key presses. In this case, we only have one component, but we want to ensure that this is the component that listens for the key presses. So I'm going to do set focusable to true. And finally, back in our app.java file, over here, I'm going to do pacman game.request focus. Alright, so make sure you have this line in app.java and these two lines in Pacman. So now if I save and run the program, I can press left, up, down, right. Okay, so the key codes for up, down, left, and right are between 37 and 40. Alright, so now that we are able to register our key presses, now when we press on an arrow key, we want to move the Pacman. So very quickly, I just want to go over how moving the Pacman works. Currently, we have Pacman over here, and if I want to move left or right, this is going to be within the x-axis. So if I move left, that's negative x, and if I move to the right, that is positive x. So the left is 0, and the right is the 18th column. And likewise, if I go up, that is negative because I am moving towards 0, and if I go down, that is positive because I'm moving towards the 20th row. So in order to move the Pacman, we need to specify a velocity. So we have velocity in the x direction and a velocity in the y direction. So we need to specify these two velocities. So here I'm going to add 3 more member variables. So car direction. And this doesn't really matter, but by default, I guess I can just set it to u for up. And we're going to create a velocity x. I'll set this to 0 for now. And int velocity y, which I'll also set to 0. If you have both velocity x and y 0, that means you're not moving along the columns or rows. Okay, so you're not moving at all. And we're going to use these same member variables for our ghosts because it is within the class block. And this is the same class we use for the walls, which don't move. So we don't really need that information, but we're just going to pack it all within the same class just to make things easier. Alright, so when I press on an arrow key, I want to update the direction. So here I'm going to create a function, void update direction, and it's going to take in a character, direction, and we'll just assign this dot direction equal to direction. And then afterwards, I want to update the velocity according to the direction. So I'll do update velocity. And this is a function that we need to define. So down here, I will do void update velocity. So for the direction, I would just use 4 different characters, up, down, left, and right. So this will be U, D, L, or R, all in uppercase. So here, I'm just going to make some checks. If this dot direction is equal to U, so up, this is only in the y-axis. So this dot velocity x is equal to 0, and this dot velocity y is going to be negative because we're going upwards towards 0, so negative. And I'm going to make it tile size divided by 4. So tile size is 32 pixels, so divided by 4 is 8 pixels. So every frame, we're just going to go up 8 pixels. And another way to look at it is every frame, we're just going to inch a quarter of the tile size. Else, if this dot direction is equal to d, this dot velocity x is 0 still because we're going down, and this dot velocity y, because we're going down, we're going towards the 20th row. So I'm going to set this to positive, so tile size divided by 4. And let's do the same for left and right. So else if this dot direction is equal to L, this dot velocity x is going to be negative because we're moving towards the 0th column. So negative tile size divided by 4. And this dot velocity y is going to be 0. And let's just copy and paste this for the last one. And I'm going to change this to R for right. And we're just going to make this positive. Alright, so if I press on a key, I want to call update direction on Pac-Man, which then updates the direction and calls update velocity. So down here, in our key released function, I'm going to make some checks. So let's just comment this out. So if e.getKeyCode is equal to key event dot vk underscore up, I'm going to do Pacman dot update direction, and we're going to pass in uppercase U. And let's just copy this and do the same for down. So else if e.getKeyCode is equal to vk down, we're going to update direction to capital D. Let's copy and paste this again. This time, vk underscore left, we will update to capital L. And then finally, vk right, we will update this to capital R. Alright, so if I press up, down, left, or right, we're going to update the direction that Pac-Man will face, and we're going to update the velocity x and y accordingly. So this will update the velocity, but we need to actually move Pac-Man. So I'm going to scroll up, and under the draw function, I will create another function called move. So we're going to do pacman.x plus equal pacman.velocityx, pacman.y plus equal pacman.velocityy. So based on our code, one of these will be 0. Therefore, I'm just going to add both of them to x and y. That way I don't need to make any checks because one of them is going to be 0 anyway. This just makes it easier to write cleaner code. But anyway, we have our move function that updates our x and y position of Pac-Man. Now we need to just call the function. So the velocity is tile size divided by 4. So every frame, we expect Pac-Man to move 1/4 of the tile size. So I want to do this before I draw. So I'm going to do move, then repaint, and that's basically how a game works. So you update the positions of all the objects, and then you redraw. Then next frame, you update again, and you redraw again. So this is going to happen in the game loop. So let's save and run the program. And you can see I have Pac-Man, and if I press up, Pac-Man moves up. And I can press left, down, right. Okay, so we need to change one thing. We need to make a check to see if Pac-Man is colliding against a wall. If so, Pac-Man needs to stop moving. So I need to define a collision function. So over here, I'm going to do public boolean collision. And we're going to take in 2 blocks. So block A, block B. And we're going to use this function to detect collision between the Pac-Man and the ghost, the Pac-Man and the wall, and the ghost and the wall, Pac-Man with the food. Therefore, we're going to reuse the same function that takes in 2 different blocks. Now, this collision function will use a specific formula for detecting the intersection between 2 rectangles. So every object, every image on our screen is a rectangle. And that includes Pac-Man. Although Pac-Man is round, the image for Pac-Man is actually a square. You just don't see parts of the square because it's invisible, it's transparent. So here I'm just going to write a formula, and because this video is already quite long, I'm not going to explain how the formula works. So just copy what I'm writing here. Trust me, it works. So return a.x less than b.x plus b.width, and a.x plus a.width is greater than b.x, and a.y is less than b.y plus b.height, and a.y plus a.height is greater than b.y. Alright, so this is going to be the collision detection formula that we'll be using for our function. Now in our move function, I'm going to make a check. So here we have Pac-Man X and Y positions being updated, and I'm going to iterate through all the walls in the hash set. So for block walls, if collision between Pac-Man and this current wall, I'm going to undo this. So pacman.x minus equal pacman.velocityx, pacman.y minus equal pacman.velocityy. So basically how this logic works is we're just going to take a step forward, and I'm going to check through all the walls. If one of them has a collision with Pac-Man, I take a step back. So after this move function finishes, it will basically be as if Pac-Man never moved if there is a wall. And just to terminate the for loop earlier, I'm just going to break. So once we find our first collision, we don't need to continue searching through the rest of the hash set because we already found the wall that we collided into. Alright, now let's save and run the program. Okay, and I'm going to move to the left, and we hit a wall. If I move up, we hit a wall, left, down, right, down, and you can see I suddenly stopped. And that is because while Pac-Man was going down, I pressed the right arrow key and suddenly it changed direction to face right. Now the thing is, Pac-Man should only change directions if it is able to. So this means that if it changes direction, it should not be in a direction where it hits a wall. And in our update direction, I'm going to store the previous direction. So carb prev direction is equal to this dot direction. And here we're just going to iterate through all the walls. So every time I update directions, I need to make sure that Pac-Man is able to change directions without crashing into a wall. So we're just going to use the same strategy. We're going to take a step forward. So this dot x plus equal this dot velocity x, this dot y plus equal this dot velocity y. And then we're just going to iterate through all the walls. So for block walls, if collision, so Pac-Man is going to refer to this. So this object, if this object collides with the wall, and we're going to use this same function for the ghosts as well because the ghosts are blocks. So if this object, which is the Pac-Man or the ghost, if it collides with the wall, then we're going to take a step back. So this dot x minus equal this dot velocity x, this dot y minus equal this dot velocity y. So we take the step back and we need to update the direction. So this dot direction is equal to prev direction. And then we need to call update velocity again. So let's save and run the program. Alright, so if I move to the left and up, and I try to move to the right, you can see Pac-Man does not stop. Unless we have an opening, like so. Okay? Alright, so that's the movement for Pac-Man. Now what we need to do is change the image for Pac-Man so that when it moves up, it's facing upwards. And if it moves down, it faces downwards. And I'm going to do that in our key release function. So whenever we press on an arrow key, it goes up, down, left, or right. We make a check to see that this direction will not result in Pac-Man crashing into a wall. So what we need to do is just simply check for the direction that Pac-Man faces. So if Pacman.direction is equal to uppercase U, we're going to do Pacman.image is equal to Pacman up image. And let's just copy and paste this. Else, if the direction is D, then this is Pac-Man down image. So let's copy and paste again. So we'll change this to L for left and Pac-Man left image. And one more time, R and Pac-Man right image. All right. And the reason why we're doing it afterwards, instead of putting it underneath each case here, is because if we update direction, it doesn't necessarily mean that pressing left will make Pac-Man move left because there could be a wall there. All right, so that's the check we made earlier. All right, so now if I save and run the program, if I move to the left, you can see Pac-Man faces left. I can go up and I can reverse course and go down. And then I can move to the right, down, left, down. All right, so Pac-Man is able to move around. Now we also want the ghost to move around. So we're going to make the ghost move around randomly. So over here, I'm going to create two new variables. So car, directions, and this is going to be an array of 4 characters. So U, D, L, and R. So this is up, down, left, and right. And we're going to create a random object. So random is equal to new random. Basically, for each ghost, we're going to randomly select the direction. So in our constructor, after we load the map, I'm just going to iterate through each ghost. So for block, ghost, ghosts, we're going to do car, new direction, is equal to directions, index of random dot next int 4. So directions has 4 characters, and random.nextInt returns a number between 0 and 4, but it doesn't include 4. So it's going to be 0, 1, 2, and 3, and I'm going to do ghost.update direction, new direction. Okay, so basically we assign each ghost a direction, and update direction will update the velocity for each ghost. Now we need to move the ghost, and we're going to do that in our move function. So we're going to do for block ghost, ghost, and we're going to do ghost.x plus equal ghost.velocityx, ghost.y plus equal ghost.velocityy, and we need to do the same check for collisions against the wall. So right now, if I save and run the program, you can see the ghosts just move in random directions and they can move past the walls. So we need to make the same check. So we're going to iterate through all the walls for each ghost. So for block wall, walls, if collision, ghost, and wall, we're going to take a step back. So ghost.x minus equal ghost.velocityx, ghost.y minus equal ghost.velocityy. And in this case, we want the ghost to change directions immediately if it collides into a wall. So we're going to do car, new direction, is equal to directions at index random.nextInt of 4, and then ghost.update direction, new direction. Okay, so for each ghost, we're going to move a step forward, and if it collides into a wall, it's going to move a step back and then change directions. Alright, so if I save and run the program, you can see this Pac-Man moves around, but the rest go off screen. And that is because we have a gap here, and this is where if Pac-Man or the ghost goes towards the left, they will teleport to the right side. And if they go to the right side, they will teleport to the left side. So I will let you implement this, and I want you to take what you learned from this tutorial and try to implement that yourself. So for the time being, I'm just going to make a quick fix. Basically, if the ghost hits this left boundary or the right boundary, it will stop and change directions. So here, I'm just going to do or ghost.x is less than or equal to 0. So the left side of the ghost touches the left border, or ghost.x plus ghost.width is greater than or equal to board width. So ghost.x is the left side of the ghost. If we want the right side, we need to add the width. So just to quickly visualize this, if we have a ghost, the x position is over here. Remember, x and y starts at the top left corner. So the left side is ghost.x. And if we want the right side, we need to add the width, which is the tile size. So over here, this will be x plus width. All right, so now let's save and run the program. All right, so now you see the ghosts each hit the left and right border and they reverse course. Now this is an issue because now these two ghosts are stuck on this row. So what we can do is we can make another quick fix, and that is if the ghost is on this particular row, we're going to try to make the ghost go upwards. So this is row number 9. So this is 9 times tile size. So if the ghost is on this row, it's going to try to forcefully change upwards. So over here, before we even move the ghost, we're going to check to see if the ghost is on the 9th row. So if ghost.y is equal to tile size times 9 and ghost.direction is not equal to up and ghost.direction is not equal to down, this means that the ghost is moving left and right, so it's stuck on this row. So in this case, we're going to do ghost.update direction u. So if the ghost is stuck on this row, we're going to try to force it to go up. So let's save and run the program. Alright, so now you can see if the ghost is in this row, it's going to try to go upwards, unless it's going up and down already. Alright, so we have our ghost moving in random directions. Alright, so now we have Pac-Man and the ghost moving around. Now we need to make them interact with each other and the food. So we need to implement 3 things here. We need to keep track of the number of lives Pac-Man has, and the score every time Pac-Man eats the food, and whether it's game over or not. So I'm going to start with score, so we're going to do int score equal to 0, and I'll also add lives. So by default, we're going to start with 3 lives, and then boolean game over, we're going to set this to false. Pac-Man has 3 lives, so this means that if Pac-Man collides with a ghost, it will lose 1 life, and if it loses all 3 of its lives, then we set game over to true. And if it's game over, we stop the player from moving Pac-Man. So let's start with the score. Every time Pac-Man collides with a food pellet, it's going to eat the food and gain 10 points. And every time Pac-Man eats a food, we want to remove that food from the hash set, because once you eat the food is gone. So here I'm going to do block food eaten is equal to null. So currently Pac-Man has not eaten anything, but we're going to iterate through all the foods. So for block food, foods, if collision, Pac-Man and the food, Pac-Man will eat the food. So food eaten is equal to food and score plus equal 10. And then we're going to remove the food eaten from the hash set. So foods.remove food eaten. Alright, so once Pac-Man eats the food, we want to update the score. So in our draw function, I'm going to add the score. So I'm going to do g.setFont, new font, Arial, font.plain, and let's make the font size 18. So if game over, currently it is not game over, but if it is game over, we'll do g.drawString, game over, plus string.value of score. And for the x and y position of the string, I'm just going to do tile size divided by 2 and tile size divided by 2. Else, so if it's not game over, we want to display the score along with the number of lives that Pac-Man still has. So we're going to do g.drawString x plus string.value of lives plus space score colon plus, and I'm just going to copy and paste this. Let's add a semicolon here. Okay. So now if I save and run the program, you can see if I move to the left, Pac-Man is eating up all the food pellets, and the score is going up by 10 each time. Okay. Now we need to make it so that when Pac-Man collides with the ghost, Pac-Man loses a life, and we reset the positions of all the ghosts and Pac-Man to the starting positions. Alright, so in our block class, we're going to add another method. So we're going to add a reset function, so void reset. And this is just going to reset the x and y position. So this.x is equal to this.startx, and this.y is equal to this.starty. Alright, so let's go back to our move function. And within our move function, in this for loop where we check collisions for the ghost, we're going to add a check to see if the current ghost has collided with Pac-Man. So if collision, ghost, and Pac-Man, we're going to remove 1 life, and then we're going to reset positions. So we need to define this reset positions. So down here, I'm going to do public void reset positions. And I'm going to do pacman.reset. So this sets the X and Y positions back to the starting positions. And I don't want Pac-Man to move until the player clicks on an arrow key. So pacman.velocity X is equal to 0. And pacman.velocity Y is also equal to 0. And then let's do the same for each of the ghosts. So for block ghost, we're going to do ghost.reset. And we're going to update the velocity. In the case for the ghost, we'll just give the ghost a new direction. So car new direction is equal to directions at index random.nextInt 4. And then ghost.update direction, new direction. So let's save and run the program. And you can see we have Pac-Man over here. And if Pac-Man collides with one of the ghosts, come on, then we reset. Okay. And then here we have 0 lives. So if Pac-Man has no more lives, we want to stop the game. So let's go back to our move function. And over here, when we collide with the ghost and Pac-Man, if lives is equal to 0, then we set game over to true. And then we return. And if game over, we want to stop drawing and moving Pac-Man. So within action performed, I'm going to do if game over, game loop dot stop. And once we stop the game loop, we will no longer call this function. Therefore, we're not going to constantly move and repaint. So let's save and run the program. All right, so we're moving Pac-Man around and let's collide. Come on. Okay, that's 1 down. That's 2 down. And 3. So we stop drawing, we stop moving the characters, and now we have game over with a score of 180. Now I want to reset the game if I press on any key so that I can try again. So let's reset the game. So in key released, I'm just going to make it so that any key press will make the game reset. If you want, you can make it a specific key. You can make it any arrow key or the spacebar key, up to you. So I'm just going to do if game over. And if we want to reset the game, we just need to set everything to the starting conditions. So I'm just going to reload the map. And the reason why I need to reload the map is because I need to add all the food back into the hash set. Then I'm going to reset the positions. And reset positions will give each ghost a new direction to move in. We need to set the lives back to 3. Score needs to be 0. And we'll set game over back to false. And then we simply restart the game loop. So game loop dot start. All right, so now let's save and run the program. And we have Pac-Man, so let's try to collide. So that's 1. Oh, that's 2. And 3, game over. Now I'm going to press on any key and it should reset the game. So the ghost will be back here and Pac-Man will be over here and all the food will reset and the score becomes 0. So I'll press any key and we reset everything. Okay, so we have 3 lives again and 0 score. All right, so now we're able to reset the game if Pac-Man runs out of lives. But there's another condition, and that is if Pac-Man eats all the food, we progress to the next level. So Pac-Man is a pretty simple game. Basically, the next level is going to be the same map, but with the food reset. Or if you want, you can create your own map. So you can make another map for the next level. But for this tutorial, I'm just going to reload the map. So in the move function, after we remove the food, I'm going to make a check. If foods dot is empty, so if the hash set is empty, that means Pac-Man has eaten all the food. And if that is the case, I would just reload the map and reset the positions. Alright, so let's save and run the program. And I would try to eat all the food. So this might take a while, so I'll probably just cut this part so you don't have to watch me try to play this game. Alright. No. Alright, so we're almost there. And honestly, this game it can be quite difficult, even though the ghosts are moving at random. Alright, there you go. Okay, so we move on to the next level, and I still have 1 life left. And yeah, so that's pretty much it for this game. Alright, so we have game over. So that's pretty much it for this tutorial. We have a fully functional game of Pac-Man. You can continue working on this game if you want. There are some features that I would like you to add, and one of those features is moving to the left of this border. So if Pac-Man moves to the left of this border, it should reappear on the right side, and vice versa. Another feature you can add is a pause feature. So by pressing the letter P, Pac-Man should pause the game, so none of the ghosts and Pac-Man should be moving. And the way you would implement this is just creating a new variable called paused and make it a boolean. And if the player presses on P, then you just flip the boolean to true and stop the game loop. Another feature you can add is keeping track of the high score. Since we can reset the game every time the Pac-Man loses all its lives, having a high score displayed over here would also be nice. And yeah, you can add other features of the game, such as adding some power pellets so that when Pac-Man consumes any of these pellets, all the ghosts become scared. So I've added that sprite over here for you if you want to implement that feature. And there's also a cherry. So you can do whatever you want with this cherry. You can add extra points when Pac-Man eats the cherry. So you can place it anywhere you want in the game. And if you want a really good challenge, you should make it so that the ghosts don't necessarily move too randomly. So in the case of this tutorial, the ghosts are just moving randomly, and every time they hit a wall, they change directions. Now the problem with this algorithm is, let's say we have this blue ghost. If it moves to the left, it goes down, and then it turns right. And technically, the blue ghost can go up, but because going up does not constitute hitting a wall, the ghost would just continue moving on. So technically, if Pac-Man is in this area, or this area, the ghost will never try to enter because it's not going to hit a wall, so it's just going to move forward. So this is all up to you. There's a lot of features you can implement, and you can find the list of suggestions on the GitHub repository. So I definitely encourage you to continue working on this game. And yeah, that's it for this tutorial. If you found this tutorial helpful, make sure you leave a like. And if you have any questions, let me know down below in the comments. And if you want to stay up to date for more tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.